Beneath an ice shell thicker than Mount Everest is tall, something may be moving, not drifting, not frozen, moving. For decades, scientists suspected Jupiter's moon Europa was hiding an ocean. But new NASA findings are changing what we think about how habitable Europa's hidden ocean could be. The question isn't whether there's water anymore, it's whether anything could be living in it. Europa has been whispering secrets for 40 years. Voyager saw the cracks, Galileo detected the magnetic signature, Hubble caught the plumes, but until recently we were missing the most critical piece of the puzzle, the chemistry that makes life possible. NASA's latest findings don't just confirm Europa's ocean exists, they reveal it might be more hospitable to life than we ever imagined, and the evidence came from a place nobody expected. When Voyager 2 flew past Europa in 1979, scientists were stunned. Instead of craters, the moon's surface was covered in reddish-brown cracks that looked almost biological, like veins beneath skin. The entire moon resembled a shattered marble, barely held together. Planetary geologist Michael Carr called it the smoothest object in the solar system, yet also the most fractured. That contradiction became Europa's defining mystery. 20 years later, NASA's Galileo spacecraft gave us the answer to one question but opened a dozen more. Its magnetometer detected something extraordinary. Europa was interacting with Jupiter's powerful magnetic field in a way that suggested an electrically conductive layer beneath the ice. The simplest explanation was a vast layer of salty liquid water, a global ocean hidden beneath the surface. A global ocean of liquid water, buried beneath miles of ice. Not small pools, not seasonal frost. An ocean thought to contain more than twice as much liquid water as all of Earth's oceans combined, kept liquid by tidal forces from Jupiter's immense gravity, the same forces that turn Io, Europa's neighbor, into the most volcanic object in the solar system. But water alone doesn't mean life. You need the right chemistry, the right energy sources, the right environment. For years, scientists feared Europa's ocean might be a sterile chemical desert, locked away from the sunlight that powers most life on Earth, sealed beneath an impenetrable frozen barrier. That fear just got shattered. The breakthrough started with oxygen. Not floating in space, not trapped in ice. Oxygen being produced on Europa's surface and potentially reaching the ocean below, and in quantities that shocked researchers. In 2024, a team led by planetary scientist Jamie Chalet at Princeton University used data from NASA's Juno spacecraft to measure oxygen production on Europa. Their findings, published in Nature Astronomy, revealed something astounding. Europa produces about 26 pounds of oxygen every single second. That's roughly 12 kilograms every single second. Here's how it happens. Jupiter's radiation belts, some of the most intense in the solar system, constantly bombard Europa's ice surface. When high-energy particles slam into water ice, they split the molecules apart through a process called radiolysis. Hydrogen escapes to space. Oxygen remains. But here's what matters. Scientists think some of that oxygen could migrate into the subsurface ocean, potentially providing a source of chemical energy. Whether enough actually reaches the ocean is still an open question. The question became, how does surface oxygen get down there? But there is a crucial detail here. Europa's ocean is not directly visible. Everything we know about it comes from measurements made from above the ice. That means every clue matters. If oxygen is being created on the surface, the next question is whether Europa's ice shell can transport some of that material downward. If carbon from the ocean can reach young regions like Terra Regio, then the surface may be giving scientists a rare window into what is happening deep below. But scientists still don't know how efficiently that exchange happens. And that uncertainty is exactly what makes Europa so fascinating. The ice isn't simply a wall separating two worlds. It may be part of a constantly changing system where chemistry from the surface and ocean interacts over enormous timescales. Europa Clipper is designed to investigate that connection. Its instruments will measure the ice shell, map the surface, study Europa's gravity and magnetic environment, and analyze the particles and gases around the moon. It won't drill through the ice. It won't photograph an alien creature swimming below. And it won't announce that life exists simply because it finds organic molecules. Instead, it will do something more important first. Determine whether Europa has the physical and chemical conditions that could allow life to exist there. That distinction matters, because the greatest discovery may not be finding life immediately. It may be proving that a second world has many of the ingredients life needs. And if Europa does, the search beyond Earth suddenly becomes much bigger. Imagine Europa's ice shell like the surface of a lava lamp, constantly churning, mixing, cycling, except instead of wax it's ice, and instead of hours the process takes thousands of years. Scientists call these features chaos terrain, massive sections of the surface that look like they've been broken apart, rotated, and refrozen in completely new configurations. One leading explanation is convection, warmer ice rising from below while colder ice sinks, potentially helping transport material through the ice shell. If ice can sink, so can oxygen, and anything else on the surface. That includes something even more intriguing. In 2023, researchers using the James Webb Space Telescope detected carbon dioxide concentrated in Europa's chaos regions, specifically in an area called Terra Regio. Geronimo Villanueva at NASA's Goddard Space Flight Center led the study, and the implications were immediate. Carbon dioxide is essential for life as we know it, and spectroscopic analysis suggested that the carbon in this region likely originated in Europa's subsurface ocean rather than being delivered from outside. Europa's ocean may be far more chemically interesting than we once thought. Evidence suggests material can move between the surface and the ocean, while oxygen created at the surface could provide a potential source of chemical energy below. That's the recipe for life. But NASA wasn't finished. In October 2024, the Europa Clipper mission launched from Kennedy Space Center, the largest planetary science spacecraft NASA has ever built. Its destination, Jupiter's icy moon. Its mission, determine once and for all whether Europa is habitable. Clipper carries 9 instruments designed to do what no previous mission could: analyze Europa's ice shell thickness, study the ice shell and ocean, map Europa's surface in detail, investigate its gravity and magnetic environment, and analyze the particles and gases around the moon for clues about its composition. The mission won't look for life directly, but it will answer the question scientists have been asking since 1979. Does Europa have the conditions necessary for life to begin, survive, and potentially thrive? Yet there's a problem nobody talks about enough. The same intense radiation that helps produce oxygen on Europa's surface is also one of the biggest threats to spacecraft operating near the moon. The radiation dose near Europa is equivalent to several million chest X-rays every single day. That's why Clipper won't orbit Europa. Instead, it will orbit Jupiter and make 49 close flybys of Europa, spending only limited time inside the harshest radiation environment. Each pass will gather data, then Clipper will retreat to a safer distance. It's a high-stakes game of scientific tag with one of the deadliest environments in the solar system. And the findings will determine whether humanity sends a lander next, or even a submarine. But there's a problem. Even the most successful flyby mission could still leave the biggest question unanswered. Europa Clipper can tell us whether the environment is habitable. It may not be able to tell us whether anything is actually alive. Here's what we know for certain now. Europa appears to have a global subsurface ocean containing more than twice as much liquid water as all of Earth's oceans combined. Scientists think that the ocean sits above a rocky seafloor, potentially creating an environment similar in some ways to the hydrothermal systems where life may have emerged on Earth. The surface may be supplying the ocean with oxygen and carbon-bearing material, while tidal heating provides a potential source of energy. It's kept liquid by tidal heating, providing a constant energy source independent of the sun. And according to research by NASA astrobiologist Kevin Hand, Europa's ocean has likely existed for most of the moon's 4.5 billion year history. Europa checks many of the boxes scientists look for when evaluating potentially habitable environments. On our planet, wherever we find liquid water, energy, and chemistry, we find life. In boiling acid pools, in Antarctic ice, miles beneath the ocean surface, even inside solid rock. Europa checks every single box. If you're looking for life beyond Earth, Europa is one of the most compelling candidates in our solar system. Not Mars, not Enceladus, not Titan. Europa. When Europa Clipper reaches Jupiter in 2030, it will begin answering questions we've been asking for half a century. But it will also confront us with new ones we're not sure we're ready for. What if we find organic molecules? What if we detect chemical signatures of metabolism? What if the plumes Hubble spotted contain microbes, frozen mid-eruption, waiting to be analyzed? And perhaps the biggest question of all, if life began independently in Europa's dark ocean, then how common is life in the universe? Because if life arose independently twice in the same solar system, it would suggest that life might be far more common throughout the galaxy than we ever imagined. If you could send one instrument to Europa's ocean, what would you want it to search for and why? Let us know in the comments. The truth about Europa isn't just that it has an ocean, it's that the ocean might not be empty. And we're about to find out.